Hi college. Okay, this is our second video on intervals. In our first video, we spent some time talking about the following vocabulary terms, which you should now be comfortable with. Let's just quickly review. The interval is the relationship between two notes. Melodic intervals are notes played or sounded in succession. Harmonic intervals are notes played or sounded simultaneously. CST is abbreviated for chromatic semitone. And when we talk about the generic quantity, we're talking about the basic number of the interval. You should also be able to identify the generic number or quantity of intervals within an octave. You should be able to look at an interval and indicate whether it is sounded harmonically or melodically, and identify the four vocal parts in choral music from highest to lowest voice with proper stem direction for each voice. So let's move on. And you'll recall this three-measure intervallic pattern here from our previous video. These are all thirds. However, if I were to play them on the piano, which I'll do in a minute, they all sound different. Now, they're all thirds, which means they have the same quantity, but each of them have a different quality. And you'll discover that intervals have both quantity and quality. So these are different types of thirds. And just like these are different types of thirds, there are also different types of unisons, seconds, fourths, fifths, sixths, sevenths, and even octaves. So let me play the first measure here. This is an A to a C. The quantity is a third. I played them melodically because that's how they are written. Listen again. In the second measure, we have this. Listen again. And in the third measure, we have an A flat to a C flat, which is also a third. So you realize that none of them sound the same. Let's listen to each one more time. In order, measure 1, 2, and then 3. What we need to do now is to be able to identify the interval quantity for all below. So here I have 5 intervals, interval V, W, X, Y, and Z. So question 1, the interval V is 1 CST blank, then interval W. First, let's go over what the quantity is for all of these below. It looks as if we're dealing with the quantity of a fifth for all of those. We have a line to a line and we count up 1, 2, 3, 4, 5, or down 1, 2, 3, 4, 5. Now that we've determined the quantity, we can look and see that the qualities are perhaps different. So, question 1, interval V, let me circle that, is 1 CST or chromatic semitone blank, then interval W. Let me circle that. So, interval V sounds as this, G to a D, and here's interval W. So because interval W has a D sharp, interval W is larger. So interval V is 1 chromatic semitone smaller. Let's erase interval V and W and go on to the next one. Interval Z, let me circle, is 1 chromatic semitone blank, then interval X. So here is interval Z. I've got a G flat to a D. And I've played it actually as written, which is harmonically. Listen again. And here is interval X. So by sound and by sight, we can see that interval Z is 1 CST larger than interval X. Interval X has a G flat to a D flat. Interval Z has a G flat to a D natural. So interval Z is expanded. So interval Z is 1 chromatic semitone larger than interval X. Let's erase those and head on over to the next question, where we compare interval Z, let me circle, with interval V. So interval Z is 1 chromatic semitone blank than interval V. Here is interval Z. Again, we have the G flat to the D. I'll play it melodically first, then harmonically. And here is interval V. So interval V is a G natural to a D natural. And interval Z is a G flat. Interval Z is a G flat to a D. So in essence, interval Z is 1 chromatic semitone larger than interval V. And that's simply because we took the G and we expanded the interval by making it G flat. So we already know what CST stands for. It stands for chromatic semitone. And this interval, this abbreviation is very important for your packets because you'll see it come up a lot. So college, let's look at these 3 figures one more time. Figure A, figure B, figure C from the previous frame. And there are 2 questions at the top that hopefully you can supply the answers to. The first question is, what do these 3 figures have in common? And how do these 3 figures differ? So take a moment to think about that and put it into words. And let's reveal the answer behind this circle. They have the same quantity, but a different quality. So remember, quantity is the generic number, so they are all thirds. That's what's the same with them. But they have a different quality because although they're thirds, they have some accidentals, which moves the chromatic semitones up or down. So now let's compare figure A with figure C. Here's figure A, and here's figure C. When both notes are lowered or raised 1 chromatic semitone, the size has not changed. So figure A has an A and a C, but figure C has an A flat and a C flat. So we've moved both pitches in figure C down 1 chromatic semitone. That means they'll have the same quality or the same size. We can scroll down a little bit and we can look at these examples right here. So let's look at the treble clef first. We see 2 intervals. Interval A, we'll call it, and interval B. If both notes of interval A, which is F and G, are raised 1 chromatic semitone, we have interval B. So here we're going from an F up 1 CST to an F sharp, and G up 1 CST to a G sharp. So the size has or has not changed? Well, hopefully you said has not. Now let's examine the bass clef intervals, interval C and interval D. First, let's realize our notes. Interval C contains a C sharp and an E natural. Interval D contains a C natural and an E flat. So lowering both notes of interval C, 1 CST produces interval D. So we took the C sharp and we lowered it 1 CST to a C natural, and we've taken the E natural and we've lowered it 1 CST, becoming an E flat. So intervals C and D are or are not equal in size. Well, hopefully you said they are equal in size. Some review questions to think of. Are intervals A and B melodic or harmonic intervals? Hopefully you said harmonic, because they sound simultaneously. Identify the interval quantities for intervals A and B. Let's page back up. Identify the interval quantities for A and B. Those appear to be seconds. Identify the interval quantities for intervals C and D. Those appear to be thirds. Okay, here's an activity we can do. We need to fill in the upper note of interval F, making the interval the same size as interval E. Let's examine our notes first. Interval E, we have an F up to a D flat. Interval F contains an F sharp, and we need to supply the upper note in interval F, making them the same quality or the same size. So in interval E, we have an F. In interval F, we have an F sharp. So we have actually raised the lower note from E to F 1 CST, which means that we have to raise the upper note from interval E, which is a D flat, up to a D natural. And I would want to put in my natural sign there so as not to be confused with the D flat. Now, both of these intervals are the same quality. And we can look at it here on the piano keyboard. Both notes of interval E are shown on the keyboard. If we take a look at interval E, we find the F, which is right here. And we have the D flat, which is right there. Now this green circle is interval F's lowest note, which is an F sharp. We've raised it up 1 chromatic semitone. And now the answer that we came up with, the D natural, would then be here as the green dot for the upper note of interval F, a D natural. So these two intervals are the quantity of sixths, and they also have the same quality because both of them have moved up together 1 chromatic semitone. So hopefully this is making some sense. Let's go on. Here's an activity we'll need staff paper for. We need to take a look at these 6 measures of harmonic intervals. And we need to expand or contract these harmonic intervals 1 CST by altering either the lower or upper note. We need to keep the generic name or quantity the same. So in the first measure, we're dealing with thirds. Second measure, thirds. Third measure, thirds. In measure 4, we have a fifth. In measure 5, we have a sixth. And in measure 6, we also have a sixth. So we've just discovered the quantity. Now I need to expand or contract according to the directions for each measure the harmonic interval's one chromatic semitone by altering either the lower or upper note while keeping the generic name the same. So just a couple of vocabulary words we should be familiar with, but we'll do a quick review. When we expand something, we make it larger. When we contract something, we make it smaller. For measure 1, we need to contract the lower note. So that means I'm going to leave my upper note as is, which is a B natural. And if I contract my lower note, I have to make this interval smaller. Right now it's the same, and adding a sharp sign here will contract the interval 1 CST. And notice that our answer is still the quantity of a third, because according to the directions, we do not want to change the quantity. We want to keep the quantity the same. In the next measure, I have to expand the upper, which means I'll leave the lower as is, which is a G. And to expand the upper means to raise it one chromatic semitone. So rather than a B flat, making this interval larger, I would need to put a B natural. Right there. In the third measure, our directions are to contract the upper, which means to make the upper note 1 CST smaller. So I have a G for my low note, and rather than a B sharp, I'm going to make it a B natural. Again, keeping in mind, I'm still dealing with all thirds. In the next one, we have to expand the upper. So my lower note will remain on an F. My top note is a C sharp. In the example, in order to expand the C sharp, I have to increase the interval and make it 1 CST larger, so I would need then a C double sharp. In the next measure, we need to expand the lower. So the upper note can stay as is on a C natural. By the way, that natural sign in the example is there, so as not to be any, so there's not any confusion between the prior measure, which had both a C sharp and a C double sharp in it. So my top note, C natural, can stay the same. I'm not altering that. I have to alter the lower note, and I have to expand the lower note. How do we expand an E? With this interval, we make it an E flat. We've just made the interval larger. And it's still a sixth. In the last measure, we have to contract the lower. So we'll leave a C double sharp for our top note. And I'm going to place the E here, but it's got to be an E something. Well, you know that contract means to lessen or make smaller. So in order to do that, we're going from an E to an E sharp. And we've just contracted that interval one chromatic semitone while still being a sixth. Okay. Now we're going to look down here, and we need to arrange these given intervals from smallest to largest. So first, what I'm going to do, and you should do this with me, is identify the generic number or the quantity for each interval. So interval V, what'd you come up with? Hopefully you said a ninth. And I'll just show you how we got there. That's how we got to the 9. Interval W is a third. Interval X, that's pretty easy. That's a P for prime. Interval Y and interval Z. Once I have my generic quantity, it's very easy for me to decipher which interval is the smallest and which interval is the largest. So we have to arrange them from smallest to largest. So in this first blank would be, hopefully you said X. Continue and see if you can fill in the rest of the blanks. What's the next smallest interval after X? Hopefully you said W, then Z, then Y, and our largest interval is V. Here's a bonus question at the bottom. One interval above is a compound interval. Are there any takers? It's interval, drum roll please, V. We're going to talk more about compound intervals later, but perhaps since I've told you that interval V is a compound interval, perhaps you may know what the term compound means. And if you don't, that's certainly okay. We'll talk about it at a future time. Here is just an answer key of last year's music theory class, and hopefully they got the same answers as I did before, and it looks pretty good. So let's proceed on. Interval quality. So all intervals have double names. The double name consists of a specific name, which is the quality, followed by a generic name, which is the quantity. And the quantity we are really good at figuring out now. It's the quality or the specific name that we have to understand. So if you recall way back from our first video, when I first introduced this unit on intervals, I mentioned to you that there are two groups of interval qualities. There are perfect intervals and major minor intervals, and you'll need to take some notes on this page because they're very, very important. So the two groups of interval qualities are, number one, perfect intervals, and number two, major minor intervals. This is going to be simple memorization, but we need to make sure we memorize that our perfect intervals are unisons or primes, fourths, fifths, and octaves. So, perfect intervals, 1, 4, 5, 8. And the remaining intervals are major minor intervals. Major minor intervals include seconds, thirds, sixths, and sevenths. I'll leave this page up for another minute so you can finish copying some things down. So let's take a look at the examples of our perfect intervals. The first one I'll circle right here. Okay, this we know is a prime or a unison, and since it is the generic quantity of 1, it is considered perfect prime or perfect unison or perfect 1. And if we needed to write both the quantity and the quality, we would write it as a capital P for perfect and a capital P for prime. Or P1 is acceptable. The one next to that, we have the generic number of a 4. So we know that it is a perfect fourth, or P4. We are going to be using capital letters, P for perfect, capital P. The next one is a perfect fifth. The generic number is a 5, and since it's a 5, it's a P5, or a perfect fifth. And the last one is an octave, so we call that a P8. Because the generic number is 8, 8 is considered a perfect interval. Below that, we have major minor intervals. Those includes intervals of seconds, thirds, sixths, and sevenths. So for the seconds, you notice that there is a minor second and a major second. And I am going to write a line over my lowercase m. And you're probably understanding now that when we're dealing with minor intervals, we're going to do a lowercase letter m with a line over it to really indicate that we're clear about our answer and that it's minor. For major intervals, we can leave it as a capital M with no line. So I have seconds that can be either major or minor. I have thirds that can be either major or minor. I have sixths that can be either major or minor. And I have sevenths that can be either major or minor. So the main thing to glean off of this page are that perfect intervals are 1, 4, 5, 8. Major minor intervals are seconds, thirds, sixths, and sevenths. Okay. So right here I have my perfect intervals in red. I've got my perfect unison, or my perfect prime, my perfect fourth, my perfect fifth, and my perfect octave. In blue, I have my minor seconds and minor thirds, and I have my minor sixth and my minor sevenths. Let's see what Homer Simpson has to say. Remember, the word perfect applies to only 1, 4, 5, and 8. The words major and minor only apply to 2, 3, 6, and 7. And Homer is telling us for now to forget about the tritone, which is the one right here. So we will forget about the tritone for now, but we'll be coming back to study that at a later time. Thanks, Homer. Okay, let's see if you can answer these 6 questions. Is there such thing as a major fourth? How about a perfect second? Or a minor fifth? Or a major unison? How about a minor octave? Or a perfect seventh? I will reveal the answer. Nope. There is no such thing as a major fourth. Remember, fourths are perfect. Is there such thing as a perfect second? No. Seconds are major or minor. Is there such thing as a minor fifth? No. Fifths are perfect. How about a major unison? No. Unisons or primes are considered perfect. Or a minor octave? Nope. It would be a perfect octave because it's an 8. And there's no such thing as a perfect seventh because sevenths are major or minor. So let's read together. We already know that the generic name or quantity of an interval is not affected by using accidentals like sharps, flats, natural, double flat, double sharp signs. Using those accidentals, however, can have an effect on its size, but not on its generic name. And when we talk about size, we're talking about the quality. Remember this example from before? This quantity is all thirds. However, each one has its own quality because accidentals affect its size. So perhaps one of them is a minor third. Perhaps one of them is a major third. So how does one determine the quality of an interval? Well, this is a little bit more complicated than simply identifying the generic name or the quantity. So we determine the quality of intervals by measuring them in half steps. So get ready to memorize this chart, and I'll put some music on and we can copy it down. It's a very important chart that's going to come in handy that perhaps we should memorize to help us figure out the quality of intervals. So here is the chart that we need to copy down and perhaps memorize, which would certainly help us when we need to identify the quality of certain intervals. So I'll put on some background music and please begin copying this chart down. college. So hopefully you copied down this chart. Now, one thing I want to point out is that hopefully you remembered to do this, and if you didn't, please do so now. But for the abbreviation column, anything that is minor, you should be putting a line over the M, like so. I should also tell you that anything that is computer generated, like worksheets or an exam, will probably not have the line over the M because it's very clear to tell in a typed out format the difference between a lowercase m and an uppercase M, but you are to include the line above a lowercase m as you handwrite these abbreviated minor intervals. And we're going to leave it at that today. And in our next video, we will explore in depth further understanding and knowledge of interval qualities. So thanks for watching, college, and have a great day.